Take a look at this Leetcode problem right here. So what we have is n staircase is given to us, and we can either do a single jump or a double jump. We have to calculate the total number of distinct ways through which we can reach the top. I'm going to be covering two solutions in this video. So before that, let's go over the brute force way to really understand what's happening in the solution. So first we have an option either to do a single jump or a double jump. If you do a single jump, you again have two more options. If you do any of those, you again have two more options, and it's pretty much the same for all the cases. You have two options for every single jump that you do. So what this tree right here does is we can actually take a chain from this tree and calculate the total number of stairs that is covered, and if there are no stairs left, then that means that is a valid combination. So let's say n is equal to 3 right now. Let's assume n is equal to 3, and let's take the leftmost chain 1 1 and 1. There is a single jump, and a single jump. 1 plus 1 plus 1 is equal to 3, and so this is a valid combination because it is equal to the staircases. Let's take the second chain 1 1 and 2, which is equal to 4. That's one more than the total number of staircases. Now here we are actually trying to jump over a stair that doesn't even exist, so this is not a valid combination. The third chain is also not a valid combination, and same with all the other cases too. So and that's how this brute solution actually works. So you have to go over a chain for 2 power n iterations and find if there are no staircases left. So 2 power n is actually a huge number when n exceeds 20 or something, and it's pretty much unreliable even for such a small constraint that is given in the problem. But let's still go over the solution, the brute force code. First I've declared a global variable called count, which actually counts the total number of ways, and right here we have the function called recursion, which is the main function, and I've given a recursion of n minus 1 and n minus 2. What is this? Well, if you decide to do one jump, you actually have one stair lesser, and that's why I've given n minus 1 here. And if you decide to do a double jump, you have two staircases lesser, and that's why recursion of n minus 2. And here we have the base cases. Well, if n equal to 0, that means if there are no staircases left, then add to the counter and break that chain. If n is lesser than 0, well, if you're going in a wrong pattern, and if you're trying to jump over a stair that does not even exist, then don't even add to the counter and just break the chain. So this is pretty much the brute force solution, and as I said, it's not reliable. It's really slow. I think it took my laptop almost 15 seconds to calculate the solution for n is equal to 45. So let's make a simple observation right here. In this recursion function, only recursion of n minus 1 and n minus 2 are the base case functions that add to the count value. So what I'm saying is count is pretty much equal to recursion of n minus 1 plus recursion of n minus 2, or we can also say this as recursion of n is equal to recursion of n minus 1 plus recursion of n minus 2. Now keep this logic in mind, as we'll be needing this to find the first solution. Now we have the base cases that is given to us in the question, which is if n equal to 1, then the answer is 1. N is equal to 2, the answer is 2. Now using the previous logic that I just discussed, n is equal to 3, we'll get n of 2 plus n of 1, which is equal to 3. And n is equal to 4 is n of 3 plus n of 2, which is equal to 3 plus 2, which is 5. And if we keep repeating this pattern right here, we'll actually get a Fibonacci series, and that is pretty much the solution, the first solution. And this is a pretty famous solution too on the internet, so I'm not doing anything new here. But the second solution right here that I'm going to discuss involves permutation and combination. So that many people might have got that method at the first, but maybe you're not been able to implement it because of some constraints. But let's go over the solution first. Let's assume n is equal to 5, and in that case we can actually do either 2 double jumps, 1 double jump, or 0 double jumps, and beyond that we cannot go. And respectively we should also do a single jumps. For 2 double jumps we need to do a single double jump. For 1 double jump we have to do 3 single jumps, and 0 double jumps we have to do 5 single jumps. So that can just be calculated by this formula n minus 2 into k, where k is the double jumps, total number of double jumps that we are doing. And so for each case right here, the total number of jumps that we are doing is just total number of double jumps plus total number of single jumps. And for the first case it's 3. We are doing 3 total jumps right here. And so what we really have to do is we have to find the total number of ways we can arrange the double jumps over the total number of jumps that we are doing. So we are doing 3 jumps in the first case, and we have to arrange 2 double jumps over the 3 jumps. So that is done by 3c2, which is equal to 3. Now apply the same logic to the second case. So we have 4 total jumps here, and we are doing 1 double jump. So that's 4c1, which is equal to 4. And in the last case it's just 5c0, which is equal to 1. And add these up and we get 8, which is the right solution for n is equal to 5. So that's pretty much the core logic here. So just iterate over total number of double jumps that you can do and find the number of ways you can arrange for each case. But there is a big problem in this code. Well, let's take the case 30c15. We have to calculate 30 factorial right here, because this is the formula, and 30 factorial is actually a very large number which cannot even be stored in a long integer. So that will give us a wrong answer obviously, and we should avoid factorial right here. So how can we avoid factorial? Well, let's try to simplify this. I write this in this form so that I can cancel the numerator and denominator, and let's expand this further and write this like this. Now this is pretty much the same as writing 30 by 1 into 29 by 2 into 28 by 3 till 16 by 15. Note this term properly because we'll be needing this to find the second solution. Let's try to write an algorithm where combination is initialized as 1, then you multiply it first by 13 and you instantly divide it by 1, multiply it by 29, immediately divide it by 2, multiply, immediately divide, multiply, immediately divide. So what this does is, as I immediately divide it every single time I multiply, it keeps the value low enough so that it never gets too big to be stored in an integer. And just carefully observe this iteration. It is pretty much equal to 30c15, and that right here is the logic to calculate combination, and combining these two we'll get this code right here. So I have a function here, climb, which calculates the total number of ways, and there is 2 for loops. The first for loop calculates the number of double jumps that you can do for given n, and the second for loop calculates the combination. Yeah, that is pretty much the code. Like and subscribe if you want to. I don't really care. Thank you. Bye bye.